Good morning friends, welcome back to your favorite channel Code One Digest. Today in this video we will learn the interface segregation principle and we will see the use cases of interface segregation principle. I'll show you a Java code implementation of interface segregation principle and also we'll discuss the benefits of interface segregation principle. So stay with me till end of this video. It is going to be very exciting and informative video. Friends, in the previous video we discussed about Lisco substitution principle. Can you explain what is Lisco substitution principle and how to use it? Please provide your answer in the comment section of this video. If you've not seen the previous video, I would recommend you to go and watch the previous video on Lisco substitution principle. The link is provided on your screen and also provided in the description section of this video. So just to recall, what is Lisco substitution principle? Lisco substitution principle states that object of a superclass should be replaceable with a object of subclass. For more information, please go and watch the previous video. Friends, here is an agenda for the video. We'll see introduction of interface segregation principle. Then we'll understand the interface segregation principle with a real world example. We'll also see a Java code implementation of interface segregation principle. We'll understand the use case of interface segregation principle. And then we'll see the benefit of interface segregation principle. At the end, I'll summarize what is interface segregation principle all about. And we'll also touch upon next video that is on dependency inversion principle. Friends, before we proceed in this video, I want you to subscribe my channel to grow Code One Digest family. Friends, I'm creating a lot of quality contents for you, but I'm not getting subscribers. I want you to like, share and subscribe my channel so that I can grow Code One Digest family. Thank you.
Let's begin, shall we?
Okay friends, so let's start with interface segregation principle. What is interface segregation principle? Let's understand that. The interface segregation principle is one of the Roberts-Martin solid design principle. Even though these principles are several years old, they are still as important to our modern systems. You might even argue that the microservices architectural style increase their importance because you can apply this principle also to microservices. The interface segregation principle was defined by Robert C. Martin while consulting for a Xerox to help them building a software for their new printer system. Interface segregation principle is the fourth principle of all solid principles we have. Interface segregation principle states that the client should not be forced to depend on interfaces that they do not use. Similar to single responsibility principle, the goal of interface segregation principle is to reduce the side effects and the frequency of required changes by splitting the software into multiple small independent parts. The goal of this principle is to reduce the side effects of using larger interfaces by breaking application interface into smaller ones. It's a similar to single responsibility principle where each class or interface serves a single purpose. By following this principle, you prevent bloated interfaces that define methods for multiple different responsibilities. As explained in the single responsibility principle, you should avoid classes and interfaces with multiple responsibilities because they change often and make your software hard to maintain. The interface segregation principle is an important concept while designing and developing applications. Adhering to this principle helps to avoid bloated interfaces with multiple responsibilities. This eventually helps us to follow the single responsibility principle as well.
Oh, wow. That's amazing.
So friends, before you understand what is interface segregation principle, let's understand what is interface. The very first question comes to our mind, what is interface? An interface is a set of abstraction that an implementing class must follow. We define the behavior, but we don't implement it in interface. Abstraction is the heart of object-oriented design. It allows the client to be unconcerned with the implementation detail of functionality. In Java, abstraction is achieved through abstract class or interfaces. So, what is interface segregation principle says? Interface segregation principle states the client should not be exposed to the method it doesn't need. Declaring method in an interface that a client doesn't need pollutes the interface and leads to a bulky or fatty interfaces. Now let's understand the interface segregation problem with a real world example. Assume we want to build a software to place order for burgers where customer can order a burger, fries or a combo of both. Since a customer can order fries or a burger or both, we decide to put all order methods in single interface. We have one interface where we have place order for burger, place order for fries, and place order for both. Now to implement a burger only order, we are forced to throw an exception in order fries method. Similarly, for the fries only order, we would also need to throw an exception in order burger method. And this is not only the downside of this design, the classes will also have unwanted side effects whenever we make changes to our abstraction layer. That is, any change to interface or abstract class would impact the implementing class. By violating the interface segregation principle, we face the problem in our code like clients are confused by the methods they don't need. Maintenance become harder because the side effects a change in an interface forces us to change the subclasses that don't implement the interfaces. Now let's see how to fix the problem that we saw in placing the order for burger and fries and combo. So in bulky interfaces, there are too many operations, but for most of the client, these operations are not used. To fix burger order application problem we discussed, we can refactor the code to have separate interfaces for ordering the burger and fries. So now having two different interfaces for burger and fries, and for the combo order, we can implement both the interfaces to have burger as well as fries in my order, right? Friends, now let's see another example of interface segregation principle that I have prepared in Java. I have prepared a Java code implementation for interface segregation principle and I have shared this project in my GitHub repository. You can download the code and play with it. You can see the repository link is shared on your screen and also provided in the description section of this video. So let me give you a code walkthrough for interface segregation principle. I have written a code in Java and I'm using Java 8 with IntelliJ IDE. And I'm going to discuss an example of transport vehicle management system to understand the interface segregation problem. Now, if you see, I have a project solid principle. Inside that, I have an interface segregation principle package. And now in this package, I have a sub package of violate interface segregation principle and follow interface segregation principle. So first, we will understand the code which violates the interface segregation principle, and then we'll discuss the later part. So assume we have a vehicle interface where we have defined different behavior of a vehicle like price, color, start, stop, and fly. So if you see this vehicle having different behavior where we are saying that a vehicle can have a price and color and also it is movable so that it can start and stop and also a vehicle can fly. Now assume we have a car implementing this interface vehicle price, color, start and stop interface makes sense to the car, but what do we do with the fly method? This method is not implementable for the car vehicle. So a class that represents an aeroplane can implement the vehicle and provide an implementation of all interface methods. But imagine a class that represents a car. This is how a car class will look like. And you can see in our code, car need to provide an implementation of fly method even though it does not require them. This is a violation of interface segregation principle. This might affect the code readability.
Wow!
Now let's see how to fix this problem of interface segregation violation. We can address the problem of vehicle interfaces that segregates the vehicle interface into multiple interfaces for a specific behavior. So in this case, vehicle interface is broken down into three different interfaces, that is vehicle, movable, and flyable. So if you see inside the follow ISP package, I have now three interfaces defined. One is vehicle, so it is having the price and color so that every vehicle will have a price and color and it will implement this interface. The next interface is movable where it shows the behavior of start and stop. Then we have third interface where it says the vehicle can fly. So based on different vehicle types, they will implement these interfaces as per their behavior. So assume for car is going to implement the vehicle interface and movable interface because car is going to have a price and a color, and also the car can start and stop moving. The same way, we will have another implementation of this interface, that is aeroplane. Aeroplane is going to implement all three interfaces, that is vehicle, movable, and flyable, because if aeroplane will have a price, will have a color, aeroplane can start moving, stop moving, and aeroplane can also fly. Hence, this is now perfectly fine in terms of interface segregation principle. We are not implementing any unwanted interface, and all the interface are segregated into their dedicated interface class, right? So now implementation class implement those interfaces they are interested in, and this helps to remove unnecessary code and is more readable.
You're good.
Friends, the very first question is strike to our mind: where and how to use interface segregation principle. So you can use interface segregation principle whenever you want a small, focused, highly cohesive software component. You can use interface segregation principle in designing and developing the microservices, where each microservices will perform the specific job. Use interface segregation if you want separation of concern in your software. Use interface segregation whenever you want to have small and dedicated interfaces. Use interface segregation principle whenever you don't want consumer to consume unwanted interfaces. Right, friends? So what are the
Really?
so what are the benefits we get out of interface segregation principle? Interface segregation principle ensures that we have a small focus and cohesive software components. It's also easy to understand and simple to follow. Interface segregation principle helps in reducing the size of interface and hence reducing the complexity, hence reducing the maintenance cost. Interface segregation principle splits the bigger interfaces into a smaller, dedicated, maintainable interface, and it can be very useful and beneficial for microservice architecture, design, and development.
No.
Okay, friends, now let me summarize what we learned in this video today. We understood what is interface segregation principle. We saw a real world example of interface segregation principle. We saw Java code implementation of interface segregation principle. And we also understood the use cases of interface segregation principle. At the end, we discussed the benefits of interface segregation principle. So friends, let me know if you have already used interface segregation principle in your project or seen a scenario where this principle can be very useful. Please provide your answer in the comment section of this video.
Leave a comment down below.
Friends, in the next video, we are going to discuss our last solid design principle, that is dependency inversion principle. We will learn what is dependency inversion principle, We will see and use cases of dependency inversion principle. I will also show you a Java code implementation of dependency inversion principle, and you will understand the benefits of dependency inversion principle. So stay tuned for the next video to come, and do subscribe to the channel if you are new to the channel. Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications, and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners, and software engineers. I am putting a lot of efforts in creating these contents, so please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.